Hello, fellow IFT students. So I thought I'd put together a video to kick off a group study session on decibels and hopefully help answer some of the hallway questions. So ultimately in wireless signals, we deal with gains and losses a lot. So to simplify the math for those, we use decibels to represent those gains and losses. So ultimately, what exactly is a decibel? It's just a measure of the ratio between two signal levels. So if we kind of put that down and really start looking, okay, what does that mean? Well, if we take a simple scenario, we have a signal in, all right, we have power level in, and that can go through an amplifier, and we're going to end up with power out. So in a simple system like this, where we're dealing with power in, single amp, power out, we can actually put some real-world pieces. Let's first kind of look at, okay, what is indeed gain? So when we're looking at this and saying, okay, we need to calculate gain, well, gain is power out divided by power in. Now, if we put real-world values with actual numerical values here, we can look and say, okay, let's say our power in is 5 milliwatt and our power out is 500 milliwatt. Well, that would mean our gain, which is just in decimal, is very simply gain is power out, 500 milliwatt, divided by our power in, which we see is 5 milliwatt. Our units cancel, and we end up with a simple decimal gain of 100. Now, we can also represent that same gain in decibels. So when we're looking at gains in decibels, what we need to look at is for gain represented as a dB, it's 10 times log base 10 of that same gain, so power out divided by power in. So that's how we'd represent our gain in decibels. So in this case, we could say, to use our real numbers, 10 log of 500 milliwatt over 5 milliwatt, and if we plug that into our calculator, we'll see that that is 20 dB. So that's our simple computation. They're equal. They work both ways. They both mean the same thing. Decibels were just put in place to try to make some of the later math easier when we're dealing with gains and losses a lot. So the nice part is we did a gain here. We went 5 milliwatt to 500 milliwatts. Decibels actually work both ways. So if we clear this and we look at a loss instead, we're going to have a signal that's coming in. That's our power in. We're going to go through, let's say this is a transmission loss, and we're going to come on to power out. All right, and so coming in to power out, if we look at real world components here, what we could do is say, okay, let's come in where our power in this case is, let's say 5 milliwatt, and the power out in this case is just 1 milliwatt. So to represent that, we're going to take that 10 times log of, and again, it's the exact same thing, power out divided by power in. So 1 milliwatt is our power out, and then 5 milliwatts is our power in. We plug that into our calculator, and we're going to find that that's negative 6.9897. So the nice part is, so what you can see very clearly, losses in decibels are always negative, gains are always positive. It makes it very easy to just look at that. And what you just ultimately need to remember is all decibels are doing is representing what is that gain or loss. It's just really a multiplier. It's what is that amplifier or what is that signal loss that you're dealing with. They themselves don't have units. So the other nice part when you're dealing with decibels is that they make some of the math a little easier when you're dealing with multiple components. So let's say we've got that same idea where we've got power in, and the first thing we do is we go through a gain. All right, we're going through an amplifier thing, then we have some losses, and then we go through some additional gains, and then ultimately here, so to our output. The nice part when we're dealing with something like this is the fact that when we're dealing with decibels, this math becomes really, really simplistic as long as everything's already been converted into decibels. So in this case, let's say we have we can make up any numbers here, a 20 decibel gain and a 10 decibel loss, and then another 5 decibel gain. Well, the great part is in order to calculate this, all we have to do is we're plus 20 dB minus 10 dB because losses are just negative, plus 5 dB, and so we're just simple addition and subtraction. We have 15 dB that we end up with. So it's really simple to deal with these chains of amplifiers or these chains of gains and losses because as long as everything's in dB, we're just adding. And that kind of brings to the last topic that we have, which is that concept of power levels. And okay, what exactly is dBW and a dBm? And in that case, what we're really looking at is that all they are decibels, which is a ratio, relative to a reference value. So when we look at a dBW, what it is relative to 1 watt. Well, what's that mean? Remember, we had 10 log P1 over P2 for defining what a decibel is. Well, in this case, all that we have to say is, well, because this is a decibel watt, P2 is fixed at 1 watt. That's it. So we look at a power level, any power level, that's just in watts, and we make it relative to 1 watt. So it becomes very, very simplistic for us to actually take that and convert to actually turn something into, into an actual dBW or a dBm because it's just defining, okay, it's relative to that item. So let's say we have transmit power, and we're saying, okay, I'm transmitting with 16 watts. All right. If I'm transmitting with 16 watts and I want that power level in dBW, it's just 10 times log power 1, which is 16. And since I want in dBW, I'm going to be referencing it to 1 watt. All right. And that's just going to be equal to, plug that into our calculator, and we can see that that is equal to 12.04 dBW. And so that becomes very simple. The next one we have is extremely similar, which is computing those instead of in dBW, dBm. Now, dBm is just shorthand for dB milliwatts, dBMW. Nobody tends to write the W, but that we just write as dBm. The only difference is instead of putting 1 watt, you end up putting 1 milliwatt. So that smaller value. So if your initial signal is in milliwatts, you don't need to do anything. Otherwise, you have to remember, of course, milliwatt. There's 1,000 milliwatts in a watt, so you just have a little bit of conversion there. So it's the same idea. So in this case, if you had 16 watts and you wanted to represent it in dBm, it'd just be 10 times log of 16 watts over 1 milliwatt. All right. And now you got to remember, you got to convert your units to make those units match. So we could represent, if we wanted 16 instead of in watts, we could represent that in milliwatts as 16,000 milliwatts. And so if we go ahead and write that out, now it's 10 log of 16,000. So 10 log of 16,000 is equal to right about 42 dBm. And so that's kind of the basics on getting started. Hopefully this is at least a little bit helpful. Good luck, everybody.